The main research object of this paper is the continuous gas-liquid reaction of MEA to carbon dioxide absorption. In this process, aspen was mainly used to simulate the tree temperature of the absorption tower. Finally, the tree temperature is predicted by mathematical modeling. The emission of industrial carbon dioxide tail gas is the main cause of the greenhouse effect, and the research on carbon dioxide absorption technology can help solve environmental problems. This is a typical flowchart of carbon dioxide absorption. In this experiment, only carbon dioxide absorption process in the absorption tower is studied. The mass fraction of the MEA solution used in this experiment is 30%, reflecting that there are 5 ion reaction formulas involved, and the thermodynamic equilibrium model includes 4 coefficients, which are A, B, C, and D. The specific value of the coefficient is shown in the table below. Aspen simulation task is to absorb 90% of the carbon dioxide in the feed gas. The gas feed conditions are constant at 46 degrees and 20 kilopascal. The liquid feed conditions were constant at 25 degrees, 2 bar, and the flow rate was set at 3.7 kilomoles per hour. The final simulation results show that the output concentration of carbon dioxide meets the absorption task of the system. The relationship between the simulated tree and the tree temperature is basically the same as that in the literature. The simulation data in the literature is basically consistent with the real value. This shows that the simulation data of this experiment is accurate. By changing the mass fraction of carbon dioxide in the feed gas mixture to analyze the sensitivity of the simulated data, the new data obtained are shown in the following table. In the sensitivity analysis, the control variable method is adopted, and the other settings are unchanged except for the carbon dioxide mass fraction and the gas feed flow. The new data was fitted with Excel to show the functional relationship, and a nice set of curves and the corresponding formulas were obtained. Combining these 4 formulas and introducing the independent variable of the carbon dioxide mass fraction of the feed, we obtain the functional relationship of the 4 coefficients with the mass fraction. Insert the formula about the coefficient into the relationship between the tree and the temperature, and finally get the overall mathematical model. The overall mathematical model can achieve a more accurate prediction of the temperature of the tree at 0.1 feet carbon dioxide mass fraction, and the temperature of the first layer tree at different carbon dioxide mass fraction. The absorption of higher feed concentration gas lacks higher accuracy. There are 3 main improvement measures required for this project. Get more actual data in the laboratory instead of relying too much on simulation software. Increase the number of sensitivity analyses and increase the database to reduce errors. Get more resources and reduce the mathematical nature of the model. Thank you.